All right, so let's start with trigonometry. And the word trigonometry is measuring a triangle, okay? So what we're going to do today is we're going to talk about trigonometric ratios. So look at this right triangle here, all right? And it's a right triangle, so we have three sides to this triangle, okay, because it's a triangle. And how do we know that it's a right triangle? What does that mean that it's a right triangle? Right, one of the angles is a 90-degree angle, all right? And it's got three sides, and in the case of a 90-degree triangle, we can label the sides with different names. They're not just called sides. One of these sides is called the hypotenuse, and that's always which side? The side that is opposite to the right angle. So opposite to this right angle, this is the hypotenuse right there. Okay? So what would the other two sides be called then? They're not sides, it starts with an L. They're legs of the triangle, right? So you have one leg here and one leg there. Okay? Now, those legs, so let me ask you another question. Of these three sides, is there one that's always the longest? Which one? The hypotenuse is always the longest. The hypotenuse is always the longest side. Okay? That will never change. Now, the two legs, they can be the same side. They can be the same size. One could be bigger than the other. One could be smaller than the other. All right? But the hypotenuse is always the longest. Now, what we're going to do is we're going to now look at the angles. So one of them is a 90-degree angle, right? Now, what would all three angles here need to add up to? 180. Okay? So if that angle here is 90, how much does that leave to distribute between the other two angles? 90. Okay? So I used up my 90 here. So these two have to add up to another 90. So that together it's 180. Okay? So that means each one of these little angles has to be less than 90. What do we call an angle that's less than 90 degrees? Back from geometry.
Acute.
It's an acute angle. So this is a right angle and it's got two acute angles. Okay? So just a little bit of terminology. So this is an acute angle. Okay. Hello? The sound? No. It may have been a different class. Okay. Right. That's never rang before. Okay, so those two are acute angles. All right, so what I'm going to do now is I'm going to pick one acute angle at random, and I'm going to do this one. Okay, so I'm going to pick one random acute angle. Now that's I sort of covered it. That's a Greek symbol. What's that symbol called? That's a theta, right? Not theta like the cheese, but theta. Okay? That's like the symbol for angle. Okay, that's the Greek letter theta. It makes the th sound. Okay, so take a look at that angle theta. Now I have the hypotenuse. That's always that longest side. That's never going to change. Now of the two legs, I have one that's touching theta. I call that the adjacent side to theta, or the adjacent leg to theta. Adjacent means touching, right? You go and rent hotel rooms, and if you rent adjoining hotel rooms, they're touching, okay? This is the class adjacent to us. That's the class adjacent to us. So adjacent means touching. The adjacent side to theta, the adjacent leg to theta is the one on the bottom here. The opposite leg to theta is the vertical one here. All right, so now we've got all our terminology down. Okay, now let me give you another right triangle right here. Okay? This is theta. And I'm going to make these two, well, let me see. Two and 8. Okay? All right. Which one of these is the hypotenuse? The 8. What about the 2? What would that be? The leg, which one? The opposite leg to theta, right? That's the opposite leg to theta. Now, what if I asked you, let's compare the lengths of the opposite side to the hypotenuse. The opposite side to the hypotenuse. So what if I were to compare the length of the opposite side to the length of the hypotenuse? How much would that be? That's 2 to 8. So how much would that be? 1 to 4. Okay? So what does that tell me? How much bigger is the hypotenuse than the leg? 4 times. Now, what if that wasn't an 8, but a 4? Then 2 times. So what would be that ratio? 2 to 4, which is 1/2. Okay? Now, suppose this side. Okay, now let's make a different triangle. Let's make this 3 and 4 and 5. Which one's the hypotenuse? 5. Now, if I wanted to compare, okay, the side of the opposite with the hypotenuse, what would that ratio be? 3/5. If I wanted to compare the adjacent side with the hypotenuse, what would that ratio be? 4/5. Okay? So this is 4/5 the size of the hypotenuse. This is 3/5 the size of the hypotenuse. What if I wanted to compare the two legs? If I wanted to compare the opposite leg to the adjacent leg, what would that ratio be? 3/4. So that means this is 3/4 the size of that one. Okay? So what am I doing? All I'm doing is comparing sides. How much bigger is one side compared to the other side? That's all I'm doing. And guess what? These ratios, this is all pretty much what trig is about. It's just sitting down and comparing sizes of different triangles. So take a look at this triangle. If I wanted to compare the adjacent side to the hypotenuse, right? How much smaller is the adjacent side to the compared to the hypotenuse? It's 3 times smaller. How much bigger is the hypotenuse compared to the adjacent side? It's 3 times bigger. So the adjacent side is 1/3 the hypotenuse. All it is a ratio. Okay? So the Greeks, way back when, rather than sitting there and saying, okay, let's compare the side opposite to theta with the hypotenuse, they just said, what's sine of theta? And that was code for what is the relationship between the opposite side to the hypotenuse. Okay? So if I wanted to compare the opposite side to the hypotenuse, rather than saying, what is the comparison of the lengths of the opposite side to theta to the hypotenuse, I just say, what is sine of theta? Okay? And if I wanted a code word for the cosine of theta, right? If I wanted a code word for what is the comparison between the adjacent to the hypotenuse, that's cosine of theta. If I wanted to compare the two legs, the adjacent and the opposite, that's the tangent of theta. Okay? So that's all these are. They're just comparisons, ratios of lengths. So the 3 words are sine, cosine, and tangent. The way they are abbreviated is SIN, COSTAN. Now, one piece of advice. We do not call them sin, cos, and tan. What do we call them? Sine, cosine, and tangent. Okay? and it's always sine of theta, cosine of theta, and tangent of theta. Okay? So I know you've seen these in geometry, so we're just recalling now. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent is opposite over adjacent. And what's the quick way to remember these? SOHCAHTOA. All right, so let's do SOHCAHTOA. Okay, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. All right, are we all okay with that one? Okay, now, what if rather than opposite over hypotenuse, I wanted to flip it and say hypotenuse over opposite? That's cosecant. And if I wanted to do hypotenuse over adjacent, that's secant. Adjacent over opposite, that's cotangent. So now we're going to introduce three more. Cosecant, secant, cotangent. Okay? Okay, so it might seem confusing at first, so let's see if we can unconfuse ourselves. So these are the reciprocals of sine, cosine, and tangent. What does it mean if you have a fraction like 2 over 5? What does it mean if you take the reciprocal of that? What do? You flip it. The reciprocal will be 5 over 2. Okay? So if I take sine and I flip it, I get cosecant. Cosine and I flip it, I get secant. And tangent and cotangent. Let me just write them here. So secant of theta, sorry, I wanted to start with sine of theta. Sine of theta, cosine, tangent. So here are the reciprocals. Now, I think the last one is easiest to remember because it's tangent, cotangent, right? The other ones, the way I remember it is the S goes with the C and the C goes with the S. Okay? If that's how I remember it. So it's sine and cosecant, cosine and secant. Okay, like the letters go opposite each other. Let's do an example with all of these. So I want to find sine of theta. The first thing you want to do is you want to label your angle theta. This is my angle theta. Now I want to label the sides as opposite, adjacent, and hypotenuse. So which one is the hypotenuse? That's the easiest usually. 13. Where is the opposite?
5.
5 is the opposite to theta. Adjacent is touching, so it's adjacent. Okay, now, sine of theta is opposite over hypotenuse. So what number over what number would that be?
5 over 13.
Is that right? 5 over 13?
Mm-hmm.
Okay, what about cosine? 12 over 13. Tangent?
5 over 12.
5 over 12. Okay? Now, when it comes to cosecant, secant, cotangent, I don't even look at the triangle anymore. For cosecant, I just take this and flip it. Take the reciprocal. I take this and I take the reciprocal. I take this and I take the reciprocal. Does that make sense? You just flip it. Okay, now, here's a little bit more of an exploration, doing that work for me. All right, so sine and cosine, because the hypotenuse is always on the bottom, these are always values less than 1. Okay? Now, if I take the reciprocal then, for cosecant and secant, if the hypotenuse is always on top, so it's always like 5 over 3, 7 over 4, 8 over 2, okay? Is it always going to be less than 1, greater than 1, or equal to 1? Greater than 1. Now, the tangent and the cotangent, right? They compare the two legs. Now, did we ever say that one leg always has, that this specific leg has to be larger than that specific leg? There is no such restriction. So for tangent and cotangent, I can have a 3 over 4. I can have a 4 over 3. So there is no restriction on the value. Okay? There is no restriction on the value. So if you remember that, that'll take you a long way. Okay? All right, let's do some special triangles. Okay. Special triangles are also pretty much ratios. Okay? Now, what is a special triangle? A special triangle is when you have a triangle that is a right angle, okay? And the angles inside are 30, 60, and 90. So that's one special triangle, 30, 60, and 90. So now, between the 30 and the 60 and the 90, which one is the largest angle? The 90. Which one is the smallest angle? The 30. Okay. So, and the 60 is the larger of the two acute angles. Okay, so now, where are the two legs? This is one leg, and this is another leg. Okay? Now, of those two legs, the purple and the blue, which one faces the smaller angle? Okay, so this is the smaller angle.
Which one is opposite?
Yeah, which one is opposite? That one. So this is the shorter leg. If that's the shorter leg, this must be the longer leg. Okay? All right. So here's how it works for 30, 60, 90 triangles. All right? You have a shorter leg and a longer leg. And the way it works is this. The longer leg is always the shorter leg times root 3. The hypotenuse is always the shorter leg times what? Times 2. Okay? So the longer leg is always the short leg times root 3. The hypotenuse is always the short leg times 2. Okay? Oh, sorry. So I'm also going to put that on the board.
Wait, why do we need to know that? Like, it already tells. Oh,
because if you're only given one, yeah. So the longer leg is the shorter leg times root 3. And the hypotenuse is the shorter leg times 2. Okay, so let's go down here to example C. If this is a 30-degree angle, then what's the angle all the way at the bottom here? 60. Now, what you want to do is this. You want to label the short leg and the long leg. So which one is the short leg? The 10. And which one is the long leg? X. Okay. So the long leg, we said, was the short times root 3, right? The long leg is X equals, how much is the short? 10 root 3. So X is 10 root 3. That's something we can do, right? Anybody have any questions? Okay, what about the hypotenuse? It's 2 times the short leg, which is 20. Okay? That's totally something we can do, right? Okay. Now, what about this next one? Yeah, now we got two triangles. Okay, divide and conquer. All right, we literally divide and conquer. So we divide this into two triangles, and I'm just gonna take that one. Okay. How big is this angle here? That's 90, and this one is 30. Okay, so if I just draw that blue one here, I get a 12, and here there is a y. Okay, and that's a 30. How much is this side here? Is that the short or the long leg? Short, yes, question. So this is the short leg, right? So short, I always like to write it. Where is the long leg here? Is that the long leg?
12.
The 12. So, sorry, hang on. So the long leg is always the short times root 3. So 12 is the short leg times root 3. So what would I do to solve for the short leg? Divide by root 3. Okay? How are we doing with that? So now, can I leave it like that?
No.
12 over root 3, that's just ugly. So what do I do? Multiply. Something like that. Okay? So 12 root 3, what do I have on the bottom? 3, so what is that? 4 root 3. Now, okay, so where is the 4 root 3 in the large triangle? It's just this part, right? This is the 4 root 3, which is this. Okay? So let me make this a little bit bigger. So this is the 4 root 3. That means how much is the entire thing? 2 times 4 root 3, which is 8 root 3. And that's my x. It's 8 root 3. All right. How much is that y over there? I'm going to go back to this triangle here. If this one was 4 root 3, okay, that's my short leg. This is the hypotenuse. Hypotenuse is what? 8 root 3. How do we get that?
8 root 3 times 2.
Right. Hypotenuse is 2 times the short leg. So 2 times 4 root 3, that's 8 root 3.
But what did you do? Oh, okay.
Okay. So that's the 30, 60, 90. And guess what? The other special right triangle, it's kind of a little simpler. Okay? So the other special right triangle is the 45, 45, 90. Okay? Now, these two are the same size angle. So in that case only, the two legs are equal sides. Okay? So in this case, the leg and the leg are the same side, and the hypotenuse is just the leg times root 2. That one is actually a little bit easier. Okay? So, take a look at example A. When you're working with special angles, with the special triangles, first you have to identify, is this a 45, 45, 90 or a 30, 60, 90? So what do you think? Is that a 45, 45, 90 or a what?
40.
How do you know?
Because both of the line.
Because the two legs are the same. So how much is x?
5.
It's 5 because the two legs have to be equal to each other. And y is the hypotenuse.
5 is 5.
Right, it's leg times root 2, so it's 5 root 2. Okay? Now, when I'm teaching this for the first time, I really try to put in as much detail as I can. Some students can just see it like that. Fine. Some students need to write it out in great detail. totally fine. I have never taken points off of a test because they showed me too much work. Okay, like that's not a thing. All right? So show me as much work as you possibly can. That's totally cool. All right, so here we go. X and Y. It's a complicated diagram. I'm going to divide and conquer. I know right triangles. Let me pick out a right triangle. This one seems to have a lot of information. Let me focus on this one. Is this a 45, 45, 90 or a 30, 60, 90?
45.
Okay. So what do I know about the relative sizes of X and Y? They're equal to each other, which is so cool because if I find one, then I've found the other. Okay? So this is a leg. This is a leg. That's a hypotenuse. And the relationship for the 45, 45, 90 is that the hypotenuse is equal to the leg times root 2.
So it's 20 equals.
So the hypotenuse is 20 equals the leg, which is x times root 2. Now what do I do?
You divide the root 2.
Divide by root 2. Okay. So go ahead and, so that was 10 root 2. Now, here is everybody's least favorite phrase. Yeah. Okay. But it's fine, because we can totally do this. So I see tangent of 30. First I freak out. And then I say, wait, 30 is like that special triangle, huh? Well, yeah. So, okay. So now I'm only like half freaking out because I can work with special triangles. Okay? 30, 60, 90. Okay? And I'm going to choose a random number for my side for 30 degrees. You know what? I'm just going to make it have a length of 1 because I like the number 1. It's so easy to deal with. Okay? So if that's a 1, where is the longer leg here? Is it the vertical or the horizontal? The vertical would be the longer leg because it faces the 60 degree. So if this is the longer leg, what is the relationship between long and short? Long is short times what? Root 3. So if this is 1, how big is the long leg? It's 1 times root 3. So now tangent, what is that? That's opposite over what? Adjacent. And oh my God, I totally have like those two sides now, like out of nowhere. That's like magic. Yes? Okay. So that's root 3 over 1. So now let's do that again. The opposite of 30, which is 1, over root 3, multiply by root 3, multiply by root 3, so it's root 3 over 3. Okay? All right, now let's do that again. All right, the secant of 45. Now, is that going to be a 30, 60, 90 triangle again? No, that's going to be a 45, 45, 90. So let's just draw ourselves a cute little triangle. And now we know that these two sides are going to be the same. So how much do I want to make one of the sides? 1. And how much is that one going to be? 1. So then how much is the hypotenuse going to be? 1 root 2, or just root 2. Now, secant. Answer this question. Is that the reciprocal of the sine or the cosine? Cosine. Remember, they go in opposite. Okay, so what was cosine? Adjacent over hypotenuse. So secant would be hypotenuse over adjacent. Root 2 over 1, which is just root 2. Okay? So you can do this like standing in line at In and Out. Like you could just go, oh my gosh, let me find what the secant of 60 degrees is. And you could just, do it. Now, and you don't even need a calculator. So again, without using a calculator, right? Without using a calculator, can we now find the cosine? Okay. So now, yeah.
I'm so sorry.
Uh-huh.
I'm a little lost. How is it root 2?
So are you okay with how we got the triangle?
Yeah.
Okay.
I don't
Now,
get that part. Like,
okay, so somebody took the cosine of a mystery angle and they got root 3 over 2. We want to find what that angle was. Okay? So now, here is a question for you. I have my two triangles, 30, 60, 90, and 45, 45, 90. Okay? Now, in the 30, 60, 90, if I label the small side 1, how much is the longer leg? The longer leg. Root 3, and the hypotenuse is 2. And the other one, if I make one leg 1, the other leg must be 1, and what's the hypotenuse? Root 2. So now, if these people got a root 3 over 2, which triangle is the only triangle where a root 3 even shows up? The 30, 60, 90 is where it shows up. So now, which angle will give us that for a cosine? So remember, cosine is adjacent over hypotenuse. So for which of these angles is the adjacent over the hypotenuse going to be that? So which one is this adjacent to? Is it? It's adjacent to the 30. So, okay, so they did something over something and they got root 3 over 2. They did adjacent over hypotenuse and they got root 3 over 2. Okay? Adjacent over hypotenuse and they got root 3 over 2. So what is this adjacent to?
30 degrees.
This is adjacent to the 30 degrees. So this is an angle of 30 degrees. Okay, just a reminder that that clock is wrong. By like 4 minutes, so we still have lots of time.
Wait, I'm so sorry. Yeah, wait, I have another stupid question. So does that just mean like whichever one's in the middle of those two?
So it has to be adjacent over hypotenuse, right? So this is the adjacent side and this is the hypotenuse. So between the 30 and the 60, what angle is this one touching? 30. So it's adjacent to the 30. That means we're dealing with the 30.
Okay.
Okay?
So that would be the answer.
That would be the answer, 30 degrees.
Oh, you're just finding what angle.
You're just finding what angle it is. You're working backwards. Okay?
Oh, okay. Sorry,
Okay.
I get it now. I'm sorry for my questions.
Totally cool. Okay. Okay. So now we have secant. And what is the formula for secant? It's what over what? It's hypotenuse over adjacent. So yeah, and you know, if you draw it once, then you can use it over and over again. So if it's hypotenuse over adjacent, so let's see, which one will give us a 2 if I do hypotenuse over adjacent? So here, can I do hypotenuse over something in the 45, 45, 90 and get a 2? No, that's a root 2. Can I do hypotenuse over something here and get a 2?
Yeah.
I can do hypotenuse over 1 and get a 2. So, whoops. So now, hypotenuse over, okay, so look. 2 over 1. Hypotenuse over adjacent, right? This gives me 2, right? Now, I'm using this side 1. What angle is that adjacent to? That's this one. It's adjacent to the 60, so this is the secant of 60. Okay?